right, everybody. Let's look at this problem that is about implicit differentiation and using that to find out different properties of the tangent line to this curve. So I'll let you read the question and I'll summarize it like this. For this curve, and I'm given this curve or this graph with the question, I can't really use it to solve the problem though. I might refer back to it though once I've solved it, and I'll tell you why that is. But I have that. I have the equation for this curve, and it says where on this curve is there going to be a vertical tangent or a horizontal tangent. Okay, so before I start answering that, let's think about what that means, like vertical and horizontal. The tangent line to a curve is just a line, and lines could be vertical, they could be horizontal, or they could be anything between. But as far as how we're going to do calculus, it's the slope that I need to focus on. The slope of a vertical line is undefined. There's no way for me to tell you, or at least attach a number to what the slope of a vertical line is. Okay, and then the slope of a horizontal line is 0. Okay, so I guess solving this as far as where on that curve is there a vertical or horizontal tangent is going to come down to this basic idea. Okay, so here's how that would relate to what I have in this question, because what I have is a curve, which you could see here if you wanted to, and given by an equation. Okay, so as far as where the tangent line is going to be undefined or vertical, 0 or horizontal, it would be a matter of solving the derivative dy over dx being undefined or 0. Okay, so how about this? Since that's what I need to do for each part of this question, part A, part B, let's start by finding the derivative. Okay, now there are 2 steps to doing that, and this is called implicit differentiation. It's how we find the derivative if we're given an equation that is not solved explicitly for y and doesn't give us y to be an explicit function of x. Here I see that the variables are mixed together. Okay, so I would take the derivative with respect to x with whatever rules apply. Like, so I may have to use the quotient rule or the product rule or whatever. Not in this case, but I would use whatever rules apply. And I get the derivative of 6, x is 6. Carry down the plus, derivative of 5y squared is 10y, but then times y prime. The derivative of negative y is negative 1, but then times y prime. And then 8 there is a constant, derivative of 8, 0. So there's my equation that introduces y prime, or dy over dx, into my work. So now if that's what you want, if you want to know what y prime is, if you want to know what dy over dx is, then you would take this, and I think it'd be reasonable to solve it for y prime, since that's what you want. So, okay, I'm going to factor out the y prime. I'm going to move the 6 over, and that'll get me to about here. And then I'll divide by 10y minus 1, and there's your y prime. If you want to call it dy over dx, you can do that. There's your derivative, no matter what you're going to call it. Okay? All right. So now let's solve the problem as it's given to us. It didn't ask me in this question to find the derivative. That's just a means to an end. Okay? So to solve the problem as it's given, I need to solve where is the derivative undefined and where is it 0. Okay? All right. So think about this. Here's the derivative I just found, and I want to figure out if it's possible to be undefined and where on the curve that would happen. Okay? So how could that, as you see it right there, that derivative, how could it be undefined? Well, what sorts of, there's some math there. I see division, I see subtraction, I see multiplication, but what about that could be undefined? What about that could be undefined is division by 0. Okay? So I'll take that denominator, I'll set it equal to 0, and that must be the key to it. That's, however that would happen, that's what's going to make this undefined. Okay? So if I do that, if I take that denominator, I figure out what's it going to take for that to be 0, I set it equal to 0, I get 1 over 10. Okay? So what did I find there with y equals 1 over 10. So what I found is the y-coordinate of the point on the curve where the tangent line is vertical. Okay, that's the y-coordinate. As it is, the question asks me, determine the points on the curve that the tangent line's vertical or horizontal. So a point, on a graph or on a curve has an x and a y coordinate. So I see it like this. Okay, I know where the tangent line is vertical. The point where that happens has a y coordinate of 1 over 10. So I'll calculate the x coordinate. And then I'll have the point, both. But what do you think we would use to find the x coordinate? Would we use the derivative? Or would we use the original equation for the curve? Okay. Well, the derivative tells us the slope of the curve. It tells us the rate of change between x and y. It doesn't tell us points on the curve. Okay. So I would use this original equation, which graphs that curve to start with. I'll put in 1 over 10 for y, since that's what I know, and I'll solve for the x. And I get x is 161 over 120. Okay? So the point on the curve with the vertical tangent line is x coordinate 161 over 120, y coordinate 1 over 10. But I want to mention this to you. It seems a little strange that they would include the graph here with this question. I cannot use this graph to solve the problem. It just doesn't have the precision. Like I kind of think like right there is where the tangent line would be vertical, but I can't tell like what that point is. I can tell this though. It looks to be slightly bigger than 1 for x and slightly bigger than 0 for y. That's where that point appears to be. So I'll ask you, look at that graph. Does the answer seem correct? 161 over 120, that's a little bit bigger than 1. I think that's reasonable. Okay. And 1 over 10 for y, that's a little bit bigger than 0. I think that's reasonable. So if this is the curve and I can see the vertical tangent right there at that vertex point is where it appears, I can't tell from looking at that picture that it's 161 over 120 and 1 over 10, but that seems realistically correct, and it is correct. Okay, I just think it's nice if we can check our answers against other information that we have. Okay, so I hope that you do that kind of thing too. What if I solved this and I got negative numbers? I don't think that'd be right, because it just doesn't look like that point has a negative x or a negative y. All right. Okay, so then I might think I must have done something wrong. I go back and look at my work. Okay, so that's part A. That's the point right here where the tangent line is vertical. Let's do part B. Part B asks, where is the tangent line horizontal? So that would amount to the derivative being 0, because that's what it means for a slope to be horizontal. Now, translating that in our question, here's my derivative. It's negative 6 over 10y minus 1. What's it going to take for that to be 0? Well, that's a fraction. So here's how that would work. Here's how division would work to get me 0. This is just arithmetic. To divide and get 0, you divide 0 by some other number besides 0. Isn't that true? So like 0 divided by 6 is 0. 0 divided by 11 is 0. 0 divided by 0 is not 0. So my conditions have to be that the top part of that fraction has got to be 0, and the bottom part has to not be 0. But this is impossible. The top number is negative 6. It's just negative 6. There's no variable up there to solve for. Negative 6 is not 0. Okay, so it's just not possible. The derivative can't be 0. At no point on the curve is there a horizontal tangent. And again, I'm not too surprised by that. It just doesn't look like this curve flattens out to be horizontal at any point. Okay, so I'm not surprised at all with B that the curve has no horizontal tangents, and it's because the derivative can never be 0. And I look at it, I'm not surprised at that at all. Okay, so there's a question that wraps up several things in the lesson. We got the process for finding the derivative if you have an implicit function, and we've got a little bit of geometry too, with lines, their slopes, what it means to be vertical, and what it means to be horizontal.